Okay, in this video we're going to look at quantum numbers and orbitals. And so we'll look at the various quantum numbers that we've studied so far. So n is the principal quantum number, and we know that it can range from 1, 2, 3, 4, so positive integers greater than 0. L has a relationship to n in that it can go from 0, 1, 2, all the way up to n minus 1 for that energy level. So ML has the range and it's dependent on L, and it can go from negative L to positive L. And MS, there's only two possibilities, and that is upspin and your downspin, or your clockwise spin and counterclockwise spin. Okay, so in each shell, there are n number of subshells and n squared number of orbitals total. Within each orbital, there are n minus 1 number of nodes. For any orbital, electron density approaches 0 at a distance of infinity. Okay, so let's start with the first energy level. So the first energy level, we have n is equal to 1. We look at our relationship. The maximum number L can get to if n is equal to 1 is 0. So that's 0. And we know 0 represents the S subshell. M sub L can go from negative L to positive L, so that's only 0. And that again is because, so that means there's only one orientation in 3D space, and that is just centered around the origin. So this orbital is given the designation 1s. And we do our calculation for the number of nodes. Number of nodes is n minus 1, so we'll say nodes is equal to n minus 1. My n in this case is 1. So in the first energy level, there are no nodes. Okay, so the first energy level only has one orbital. And one orbital can hold 2 electrons. So the first energy level is only capable of holding 2 electrons. The second energy level, okay, so when n is equal to 2, I can have 0 for L, but I can also have 1 for L. So 0 means the S subshell, and 1 means the P subshell. Remember that the S subshell, the ML value can only be 0. So that means that there's only one orientation in 3D space. So this is the 2s orbital. Now, let's take a look at the nodes. Nodes is equal to n minus 1. So this is 2 minus 1. So I have one node. Now, you can do a further calculation to determine what type of node will be present. If you scroll down here, it tells you the number of nodal planes or angular nodes is given by the letter L. And the number of spherical nodes is given by the calculation n minus L minus 1. So let's take a look and see how many nodal planes are in the 2s subshell. So number of nodal planes should be equal to L. I look at L, L is 0, so therefore no nodal planes. But I still have one node. So what is that node? Well, let's take a look. That node would have to be a spherical node, and that is in fact what we see here. We see a spherical node. So we can actually mathematically calculate the types of nodes that are present, and then that should be confirmed in the diagrams that we see. Okay, so that's my 2s orbital. Now what we have is the p orbitals, and there's 3 of them, and that's because ML can range from negative 1 to 0 to positive 1. And so there's 3 possible orientations in 3D space. If we look at this, we see that we have one where the antinodes lie on the y-axis. So this is 2py. This subscript designation is where the antinodes lie. So antinodes, remember antinodes being like the locations of high probability of finding an electron, antinodes on y-axis. Okay, and so we say 2py, right? We take a look. My nodes is n minus 1, so 2 minus 1. Okay, so I should have one node. And so let's use our formulas here and determine what type of node we have. Well, it says number of angular nodes is equal to L. Okay, so L is equal to 1, so I have one nodal plane, and that seems to make sense. So I have a nodal plane along the XZ plane. So I'm going to try and sketch that out here, and hopefully you can see what I'm trying to draw. So along the XZ plane is basically like there's this plane that goes along here, right along the XZ. Okay, and all on this surface right here, we can have no electron probability, or zero electron probability. In this case right here, this would be the 2pz orbital. Okay, and so we have a nodal plane. If the antinodes are on the z, then the nodal plane is going to be along the x and y right here. Okay, so that's where my nodal plane is. So nodal plane on xy plane. Here, the nodal plane was on the xz plane. And then over here, my antinodes are along the x, as seen by the designation there. So I say 2px. And the nodal plane along yz. Okay, so nodal plane along yz right here. Okay, and so all along the yz, there can be no electron. Okay, now we'll write that in. Okay, so if I look at this right here, at the second energy level, this can fit 2 electrons, this can fit 2 electrons, this can fit 2 electrons, and this can fit 2 electrons, for a total of 8 electrons in the second energy level. All right, in the third energy level, we can see we've got yet another 3s subshell. So the subshell is S. And I look at this right here. I use my equations to determine how many nodal planes there are. So nodal planes is L. L is 0, so there's 0 nodal planes, but how many nodes should there be? Nodes is equal to n minus 1, so there should be 2 nodes. Okay, 2 nodes there. And then if there's no nodal planes, then both of those nodes have to be spherical nodes, and that's what we see right here. Okay, so 2 spherical nodes. In the third energy level, I can also have a p subshell as well. Okay, and my m sub l is -1. 0 and 1, because it's dependent on L and can go from -L to +L. And then what I'm going to do right here is I'm going to say that this right here, I'll just draw this in. I'll say that this is the y-axis right here, along here. Okay, that's my y-axis. All right. And so that means that this right here, if up and down is my y-axis right here, okay, and okay, we'll call this one my x-axis, and I'll just draw in a z-axis over here. Okay, so we can see that the antinodes, right, these dark regions of probability are sitting on the y-axis, so we call this one 3 py. Now you might be wondering, okay, well, it doesn't really look like p because p is 2 lobes and I see 4 lobes here. Well, that has to do with the nodes. So if we take a look, nodes is given by n minus 1, so 3 minus 1. So I know I have 2 nodes. But then my nodal planes is given by L, and so that's just, I have one nodal plane. Okay, and so hopefully you can see that I've got a nodal plane along the XZ axis. So I'll try and do it in a different color here so you can see it. Okay, so XZ, I've got a nodal plane here that cuts this into 2 symmetrical portions. So it goes right along the middle. But then if I look at spherical nodes or radial nodes is given by n minus L minus 1. So 3 minus 1 minus 1. So I have one radial node. And hopefully you can see where it is. The radial node is actually in the middle here. And it kind of is in between these two regions. You can see that there's a lighter region right here. So we have a nodal plane that cuts through the middle and then a spherical node that goes around it. This right here is another orientation. So we'll call this one 3pz and we'll call this one 3px. So again, if I preserve my orientations, this is y, this is z, and this is, we'll call this one my x. So this means that my antinodes are going to be along the, z axis. So let me draw these antinodes. So I have these 2 lobes right here, right? These 2 smaller ones, right? And then around them, I have other regions of high probability, similar to what we see here, but just now oriented along the z-axis. Not my best work, but okay. So if we try to locate, again, we're going to have 2 nodal planes, or so we're going to have a nodal plane along the y-axis, so as we can see there, along y-axis. Y-axis cuts this into 2 regions, right? This region along the z-axis in front and the region along the z-axis and below. So right along this 2-dimensional y-x plane, we can have no electron probability. And then we can also see that there is a spherical node that goes in between the individual lobes of high probability. All right, see if you can sketch for yourself the one for 3px. I'm just going to pause the video, and when we come back, it'll all be drawn for you. So see if you can figure this one out on yourself. Just press pause. Okay, so that's what the 3px should look like. Notice that the antinodes are along the x-axis, okay? And we have both a nodal plane along yz and a radial node that separates the lobes of high probability. Okay, finally, these ones you won't really ever have to sketch. I've given them to you right here. So we can see that, so we've dealt with 3s and the 3p's, but in the third energy level, we also have L is equal to 2. And remember that when L is equal to 2, that is the D subshell. And there's 5 possible orientations in 3D space, so -2, -1, 0, 1, and +2. And so we can see right here, when we have 3D x squared y squared, that means that the antinodes, that's the notation for antinodes on the x and y axis, all right? And so this orbital would be given as 3D x squared minus y squared. Over here, we see the antinodes are on the YZ plane, so we say 3DYZ. Over here, this one's a little more difficult. It's along the z-axis. We can see that the antinodes are along the z-axis, but it's also got this z squared, and that's because there is a nodal plane then the form of a parabola coming here. I'll actually do it in red right here. So we've got a nodal plane that comes like here. Okay, it's in the form of a parabola, so it's a parabolic shape. Okay, and down like that as well. So two nodal planes there. So we give this one the designation of 3dz squared. And then this one is 3dxz. Again, the antinodes are on the xz plane. And same over here, 3dxy. If we take a look at the nodes, again, if n is equal to 3, the number of nodes is 2, and we see from our equations right here that the number of nodal planes is equal to L. So there are 2 nodal planes in each of them. Well, I already showed you that there's 2 nodal planes in the forms of parabolas here. If the antinodes are on YZ, then the nodes here are on the other planes. So the nodes here are on XY, and hopefully you can see that right there. There's a nodal plane here. And then there's also a nodal plane along XZ as well. Okay. So there's 2 nodal planes. We'll write that right here. Nodal planes on XZ and also XY. So the other planes that are not where the antinodes are, right? The antinodes are on the YZ. Okay, so this is a pretty thorough description of all the possibilities for your orbitals. One thing I should show you as well is remember that each of these orbitals contains 2 electrons. So in the third energy level, if each of these orbitals contains 2 electrons, you should see that in the third energy level, we're capable of fitting a total of 18 electrons. So first energy level, 2 electrons. Second energy level, 8 electrons. Third energy level, 18 electrons, 2 in each of these orbitals.